Our universe is a marvel of interconnected systems, a vast expanse where energy flows seamlessly from one form to another. From the largest galaxy to the smallest atom, energy flows and transforms, creating a delicate balance that sustains life and drives the cosmos. In our quest for sustainable living on Earth, we constantly seek new ways to harness this energy, striving to find solutions that are both innovative and environmentally friendly. Crystal batteries represent an exciting development in this search, offering a new way to store and utilize energy that could change the way we think about power. Imagine a battery that is not a bulky box but a shimmering crystal, a beautiful and efficient energy source that could fit seamlessly into our lives. This is the promise of crystal battery technology, a revolutionary approach that harnesses the unique properties of crystals to store and release energy. They offer a glimpse into a future powered by clean, sustainable resources, where our energy needs are met without harming the planet. Join me as we delve into the fascinating science behind these tiny powerhouses, exploring the cutting-edge research and innovations that are making this future a reality. Crystals are more than just beautiful objects. They are marvels of nature that captivate our imagination and curiosity. They are highly ordered structures at the atomic level, where atoms are arranged in a precise repeating pattern. This meticulous order gives them unique properties that we can harness for various applications, including energy storage. Borax and potassium chloride, two readily available materials, play a crucial role in the world of crystal batteries, offering a sustainable and efficient solution. Borax, commonly found in laundry boosters and cleaning products, possesses an unusual ability that sets it apart. It can conduct electricity when dissolved in certain liquids, despite being an insulator in its solid form, making it incredibly versatile. This unique property makes it a key ingredient in our innovative crystal battery technology. Potassium chloride, often used as a salt substitute in dietary applications, is our other hero in this story. When combined with borax and dissolved in water, it creates a pathway for ions to flow freely. These ions are the carriers of electrical charge, forming the basis of the battery's operation and enabling the storage of energy. When we apply an electrical current to this solution, a fascinating electrochemical process occurs. The borax and potassium chloride molecules arrange themselves in a specific ordered pattern, forming a stable crystal lattice. This crystal acts as a storage container for the electrical energy, holding it until it is needed. The beauty of this process lies in its simplicity and elegance, demonstrating the power of natural materials. By using common materials and harnessing the natural tendency of crystals to form ordered structures, we can create a powerful and efficient energy storage device that is both accessible and sustainable. In the next section, we'll explore in greater detail how this crystal becomes the heart of a functional battery, powering devices and systems with remarkable efficiency. Like any battery, our crystal battery needs two key components, an anode and a cathode. These are the fundamental building blocks that allow the battery to function. These components act as the entry and exit points for the electrical current, enabling the flow of energy. Without them, the battery would be unable to generate or store power. Let's delve into how we create these essential parts using our borax and potassium chloride crystal. These crystals are not just ordinary substances, they play a crucial role in the battery's overall performance. To create the anode, we need a material that readily gives up electrons. This is a critical step because the anode's ability to release electrons determines the efficiency of the battery. This electron-rich material will serve as the negative terminal of our battery. The negative terminal is where the flow of electrons begins. A common choice is zinc, a readily available and reactive metal. Zinc's properties make it an ideal candidate for the anode, ensuring a steady supply of electrons. For the cathode, we need a material that attracts electrons, acting as the positive terminal. The positive terminal is essential for completing the circuit. Here, we can use copper, another readily available metal with good electrical conductivity. Copper's ability to attract electrons makes it perfect for the cathode. Now, imagine immersing the zinc anode and copper cathode into our borax and potassium chloride solution. This solution acts as the electrolyte, facilitating the movement of ions between the anode and cathode. When we connect the anode and cathode with a wire, a circuit is created. This connection allows electrons to flow from the anode to the cathode. The chemical reaction within the battery causes electrons to flow from the anode to the cathode through this wire, generating an electrical current. This current is what powers our devices. This flow of electrons is what powers our devices. From smartphones to electric cars, the movement of electrons is the driving force behind modern technology. The borax and potassium chloride crystal, with its unique properties, acts as the heart of this process, facilitating the movement of ions and enabling the storage and discharge of energy. These crystals ensure that the battery can efficiently store and release energy when needed, making them indispensable to the battery's operation.